Is it on? Okay, in this episode of AI Slop, Eric Stalewaters and Lara are talking about the differential transform, which aims to focus on relevant context by canceling out attention noise. The model calculates attention scores as a difference between two softmax attention maps, effectively filtering out distracting information. Now I'll pass the torch to our hosts, and God bless America.
All right, ready for another deep dive. This time, we're jumping back into the AI world, but with a twist.
A twist?
Well, we're always talking about the latest and greatest AI, right? But let's be honest, it still feels like it's missing something.
Yeah, for sure.
Like, we're promised these super intelligent machines, but then you try to get a chatbot to help you order a pizza and it starts rambling about the history of pepperoni.
Oh, tell me about it. I swear, half the time I spend with these things is trying to get them back on track.
Right. It's like they have a serious attention problem or something.
And that's actually not far off from how researchers are describing it. This paper you sent over, the one about Diff Transformer, it's basically trying to tackle that exact issue, how to make AI less distractible.
Diff Transformer.
Ah.
Okay, that sounds kind of intimidating. Is this where I need my computer science degree?
Don't worry, I promise it's not as complicated as it sounds. Think of it this way. Imagine trying to have a conversation at, say, a really loud concert.
Been there, done that, got the tinnitus to prove it.
Right, so there's all this noise around you, and it's really hard to focus on what the other person is saying, right?
It's like trying to work in a busy coffee shop. Way too much input.
Exactly. And in a way, that's what's happening with a lot of AI right now. They're getting bombarded with so much information that they struggle to figure out what's actually important.
They're getting distracted by all the noise, just like us in that concert.
Exactly. And that's where this attention thing comes in. See, current AI models, those using transformers, they create something called an attention map.
An attention map. So, like a roadmap for their brain, showing them where to focus.
Sort of. It's how they try to figure out which parts of a text are the most important. The problem is, these maps often get cluttered with irrelevant stuff. The paper calls it attention noise.
So instead of highlighting the important parts, they're circling every other word.
Pretty much. And that's why they get sidetracked so easily. They're paying attention to everything, not just the important stuff.
Kind of like how I end up down a Wikipedia rabbit hole when I'm supposed to be writing a report.
A very relatable struggle. But with DIF Transformer, they're trying a different approach. Instead of one attention map, they create two.
Two maps. So twice the confusion.
Not quite. They actually subtract one map from the other.
They subtract them. Okay, now I'm really lost.
It's like noise-canceling headphones, but for AI. By subtracting the maps, they cancel out anything that both maps considered unimportant. What's left is a much clearer signal.
So instead of trying to focus on everything at once, they're filtering out the distractions from the start.
Precisely. It's about making the AI more selective in what it pays attention to, just like we have to do in a noisy environment.
Okay, that actually makes sense. But do we actually see that in how well it performs? I mean, does this differential attention thing actually make a difference?
That's the million-dollar question, right? And the short answer is yes, it seems to. They tested DIF Transformer on a bunch of different tasks, and the results are pretty interesting. One of the things they looked at was key information retrieval.
Key information retrieval. What's that?
Imagine you have a mountain of data, tons and tons of text, and you're looking for one specific fact, one crucial piece of information buried within it.
So every research project I've ever done.
Exactly. And what they found was that DIF Transformer was consistently better at finding that needle in a haystack, especially when they were dealing with really long, complex texts.
So it's not just that it's paying more attention, it's that it's paying attention to the right things.
Exactly. And this focused attention has some other really interesting implications. For example, the researchers also looked at something called in-context learning. It's basically how AI learns from examples.
Okay, so instead of just throwing a bunch of data at it, it's more like, here's a few examples, now you figure out the pattern.
Right. It's like how you teach a kid to tell the difference between different animals. You show them pictures of cats and dogs, and eventually they start to get it.
Makes sense. Except I'm guessing this AI learns a bit faster than a toddler.
Oh, yeah, definitely. But what's really interesting is that DIF Transformer wasn't just better at this kind of learning, it was also less sensitive to the order of information.
What do you mean?
So current AI models, they tend to get thrown off if you change the order of things, but DIF Transformer was much more adaptable.
So it's not just about what you're paying attention to, but also how those things are connected, even if they're in a different order.
Exactly. And that's a big deal for natural language processing, right? Because with language, the order of words can totally change the meaning.
That's true. You can't just shuffle words around and expect the same result.
Right. So this ability to understand context, even when the information is presented differently, that's a big step towards making AI more, well, human-like in how it thinks.
Okay, I'm seeing the potential here. But let's get practical for a second. We keep talking about AI getting smarter, but all this processing power, it takes a lot of energy, a lot of resources.
Yeah.
Is this Diff transformer thing just adding to the problem?
Actually, that's the really cool part. Not only does it seem to learn faster, but the research suggests this approach might actually be more computationally efficient.
Wait, hold on. So we could have smarter AI that's also less demanding on our hardware.
That's the idea. And that has huge implications. Imagine being able to run these powerful AI models on, say, your phone or even smaller devices.
You're talking about making AI way more accessible, giving it a much wider reach.
Exactly. And opening up a whole new world of applications for AI that we haven't even thought of yet.
Okay, this is getting really exciting. So we've got AI that's better at focusing, learning, understanding context, A&D. It might even be more efficient. This is starting to sound almost too good to be true. But what does this all actually mean? Like, how does this translate into real-world change? It's like we're finally addressing a bottleneck we didn't even realize was holding AI back. Like, who knows what we could accomplish if AI could just, focus on the right things?
That's what a lot of researchers are excited about. This could be a game changer for fields that rely on analyzing huge amounts of data. Like, think about medical research.
Oh, wow, yeah. We could be talking about finding cures faster, developing new treatments, even personalizing medicine.
Exactly. Or imagine what this could mean for education. We could have AI tutors that can actually understand a student's individual learning style, figure out their strengths and weaknesses, and adapt to their needs in real time.
That would be incredible. Yeah, what about something like fighting misinformation? Could this help us tackle things like fake news and deep fakes more effectively?
Absolutely. Remember how we talked about how Diff Transformer seems to be better at avoiding those AI hallucinations? Those times when AI just makes stuff up?
Yeah, because it's not getting sidetracked by all the irrelevant noise.
Right. So if it's less likely to get fooled by distractions, it might also be better at spotting those subtle inconsistencies that often signal fabricated content.
That's a huge potential benefit, especially in today's world. But, there's always another side to these things, right? Making AI more efficient, more powerful. It comes with some big questions, too.
I think that's a crucial point. Just because we can do something doesn't always mean we should. Developing this technology responsibly, ethically, that's got to be a top priority.
We need to make sure it's used to benefit humanity, not create new problems or worsen existing ones.
Exactly. We have to be really thoughtful about the potential consequences, both good and bad. This technology is a tool, and like any tool, it can be used in many ways.
And that's what I find so fascinating about these deep dives. We're not just geeking out over the latest tech here. We're talking about how these advancements could reshape the world around us.
It's about understanding the bigger picture, asking the tough questions now, so we can make informed decisions about the future we want to create.
Because this isn't science fiction anymore. This is happening right now, and it's moving fast.
It absolutely is. And that's why conversations like this are so important. The more we understand about AI, its potential, and yes, its risks, the better equipped we'll be to navigate this new landscape.
Well, you've definitely given me a lot to think about. Thanks for joining me for this deep dive. It's been eye-opening. And for everyone listening, keep those questions coming, keep learning, keep exploring. Until next time.